Imagine stepping onto a distant world. The air isn't breathable, the ground isn't rock as we know it, and life, if it exists, might not resemble anything from Earth. Forget the green humanoids of Hollywood. Real alien life, if we find it, could be utterly unrecognizable. Today we're diving into xenobiology, the science of imagining what life could be like beyond Earth, based on physics, chemistry, and biology. Movies often give us aliens with 2 eyes, 2 arms, and a mouth. Convenient for actors in rubber suits, but not very scientific. The universe is not obliged to make life symmetrical, humanoid, or even carbon-based. Real alien life may stretch the limits of what we call biology. So let's set aside science fiction for a moment and explore possibilities grounded in real science. What could life actually look like out there? Here on Earth, life is built on carbon. Why? Because carbon forms stable, complex molecules, perfect for the chemistry of life. But carbon isn't the only candidate. Scientists often consider silicon-based life. Like carbon, silicon can bond with multiple atoms and form complex structures. Imagine crystalline organisms growing in desert-like worlds, shimmering under alien suns. They might metabolize differently, perhaps breathing sulfur or exhaling quartz-like waste. But silicon has limitations. Its bonds are less flexible, and it doesn't thrive in water the way carbon does. So if silicon life exists, it might favor hotter, drier planets, worlds that look inhospitable to us. Life on Earth depends on water. But what if there's life swimming in something else entirely? Ammonia, for example, could serve as a solvent for alien biochemistry. On frozen worlds, we might find creatures with slower metabolisms, ammonia blood flowing through strange bodies. On Titan, Saturn's largest moon, rivers of methane and lakes of liquid hydrocarbons exist. Could there be methane-based microbes? Perhaps even complex life that drinks methane instead of water? Even exotic solvents like supercritical carbon dioxide or liquid hydrogen could support life under the right conditions. To us, these places are toxic, but for alien life adapted to them, Earth might be the real death world. Not all life needs a surface world. Moons like Europa and Enceladus have thick ice crusts covering vast subsurface oceans. Beneath the frozen shell, hydrothermal vents could provide heat and nutrients. Picture ecosystems like Earth's deep-sea vents, giant alien tube worms, microbial mats, and strange crustacean-like beings thriving in complete darkness. These life forms might never see the stars, evolving in isolation beneath miles of ice. Now let's go bigger. What if life floats in the skies of gas giants like Jupiter or Saturn? Carl Sagan once proposed enormous floaters and sinkers, vast balloon-like organisms drifting in thick atmospheres, feeding on chemicals or sunlight, while smaller predator organisms hunt them. Imagine living gas bags the size of cities, bobbing in turbulent alien skies. It sounds wild, but the chemistry works. On Earth, we already have tiny airborne microbes and spores. Scale that up, and entire alien ecosystems could float in the clouds. The farther we stretch, the stranger it gets. Some scientists speculate about plasma-based life in stars, entities formed from magnetic and plasma interactions. Others imagine a shadow biosphere right here on Earth, life so chemically different from ours that we may have overlooked it. And some even wonder if life could exist as patterns of information in electromagnetic fields or quantum structures. These ideas are speculative, but they remind us that biology doesn't have to follow our rules. Why do we explore these ideas? Because when we search for life beyond Earth, our assumptions guide what we look for. If we only search for Earth-like life, we might miss alien biologies hiding in plain sight. The universe is vast. Out of trillions of planets, some will host life, maybe even intelligent life. But if we ever meet it, chances are it won't look like us. It might be crystalline, ammonia-breathing, floating in clouds, or swimming in an alien ocean beneath an icy moon. So the next time you see a sci-fi movie with aliens that look like humans in green makeup, remember, real extraterrestrial life could be far more exotic, far more bizarre, and far more fascinating. We may not know what aliens look like yet, but one thing is certain, the universe is stranger than we can imagine. If you enjoyed this dive into xenobiology, hit the like button, subscribe, And let me know in the comments, what kind of alien life do you think is most likely out there? Because the truth is, the answer might already be waiting for us, just beyond our reach.